In the analysis and test of electronic circuits, it is often, Alright, so in the analysis and test of electronic circuits, it is often useful to connect one resistor in parallel to another to obtain a non-standard value, one which is smaller than the smaller of the two resistors. Often, particularly during circuit testing, one resistor is already installed, in which case the second one connected in parallel is said to shunt the first. If the original resistor is 10 kilo ohms, what is the value of the shunting resistor needed to reduce the combined value by 1%, 5%, 10%, and 50% of the original 10 kilo ohm resistor value? Alright, let's do that question first and then we'll do the second part. And I'm going to make a general formula so you can use it in the future, which comes up actually in this textbook. Sometimes you'll have a 100 kilo ohm resistor, and they're going to want you to shunt it to some value. And see if we can get a general formula. Alright, so the parallel equation, right? The equivalent parallel resistance is equal to R1, R2 over R1 plus R2. Right. For this general equation I want to make, the parallel resistance is going to be some percentage. So here they wanted us to reduce 10 kilo ohms by 1%, or 10% or whatever. So let's make R1, like the resistance, the one we have, right? So then RP is going to be 1 minus some percent, called X%, of R. So minus 1%, you'll have minus 0.01, and then you have 0.99. 0.99 times R, so equals R, and then R2 will be the shunting one, RS for that, and then R plus RS. Alright, so let's see, let's carry this out to see, to get an expression for RS. We can cancel out R, and then let's multiply that out. So then we'll have, and let's just call this, I don't know, dude. I'm gonna use this E because I want to. So E, R plus RS equals RS. Right? We multiply that, and then so then let's subtract this RS. So then we'll have this ER equals RS, minus this ERS. So we pull out the whatever, so then we'll have ER divided by 1 minus E is equal to RS. So that means that we can take any resistor value 10 kilo ohms, and then we can plug in E, so that would be 1 minus X%, so 0.99%, and then that's how you get RS. I think you could use that like in the future. So let's just do it for 10 kilo ohms and reducing by 1%, 5%, 10%, and 50%. Okay, so I'm gonna leave that formula there. Get rid of everything else. And do this. So 10 kilo ohms is R, and we want to reduce it by 1%, right? What would that give us? That's easy, right? So we'll put 0.99 here, 1 minus 0.99 there, plug in R equals 10K, and we'll get it. So, okay. Give me a sec, I can't do this right here. There it is. So the shunting resistor will need is 990,000. That's right. 990,000. I'll double check it for you just once. So we'll multiply that by 10,000, and then divide that by, seems to be 1 million. And if you carry that out, you'll get the parallel resistance will be that, and that's exactly 99% of 10,000. So there you go. Yeah, it works. Okay, so what about 5%, 10%, and 50%? All right, I'll do it for you. 5%, 10%, 50%. That'd be 0.95. And that would be, okay. Shunting resistor would be 190,000. About 10%. Okay. 90,000. And 50%. Let's see. Oh, that one's easy. That's just 10. 10 kiloohms. Alright. There you go. Alright, let's do part 2 of the question. So, what is the result of shunting a 10 kilo ohm resistor by 1 mega ohm, by 100 kilo ohms, by 10 kilo ohms? Alright, that's easy. You know the parallel equation. We said it earlier, so I'll just do them for you. So 10 kilo ohms in parallel with 1 mega ohm. And then, what's the other one? 100 kilo ohms and 10 kilo ohms. Okay. So, that'd be 10,000 times 1 million divided by 10,000 plus 1 million. And that would be 9,900. What about this one? That'd be 10,000 times 100,000 divided by 110,000. That'd be 9,090,90. Kind of repeating. Probably, I think. And this one would be 5 kiloohms. Just half. There you go.